Section 1.5, the first day of notes, we're going to be talking about rational numbers, okay, specifically relating to Venn diagrams. Now, before we use the Venn diagram, we need to know how one works. Okay, you've seen the Venn diagram that represents up there. It's two ovals or two circles, and whenever the two circles are covering each other, they have areas in common. Let's see, I'm going to highlight as I talk. The overlapping areas show that what is common between both groups. For example, in the last chapter, we talked about factors. We have factors of 24, which are 1, 2, 3, 4, 6, 8, 12, and 24. Then there's also factors of 36. Factors of 36 include 1, 2, 4, 3, 4, 6, 9, 12, 18, and 36. Okay? So you recognize that Venn diagram, right? So that means that all the stuff, we'll go like this. So all the things that, these are all the factors of 24. Let's move this down. Okay? Here's all the factors of, so I'll do the factors of 36 in blue. So then you'll see what's in the middle that is both blue and yellow, which is green. Ah, yes. Yes. Okay. Yes. Science. Yes. Now, so the parts that are blue and green are factors of 36. The parts that are yellow and green are factors of 24. Now, where would we put numbers that are not factors of either 24 or 36? Where would we put those numbers? Yes, outside the circle. So I want you to write a 7 out here, and then write down outside the circle right here. And then it says, for the second part, what is so special? What is special about the numbers in the overlapping area? What's special about them? Yeah.
They go into their factors of both of the numbers.
Good. Factors of both numbers. So would it be safe to say they're common factors? Oh. And since we just took that test yesterday, or by yesterday I mean Friday, what is the greatest common factor inside this part? Yeah. 12. So what's the GCF of 24 and 36? 12. Oh, everything builds on each other. I love it. It's like a big giant building, and you need a floor. Now, this is kind of a weird shaped Venn diagram. One is a little bit bigger than the other. Okay? Do you agree?
Yeah.
Now, look at the diagram that's below the Venn diagram that you're used to. Those are not the rings of Saturn. Okay? That is a Venn diagram where this is happening. You have a Venn diagram just like this, but rather than only having a small portion in the middle where they overlap, everything in this smaller circle goes along with a bigger circle. See that? Still a Venn diagram, but rather than looking like this, it looks like this. Thank you. Now, let's fill this one in together. We want to show the relationship between certain classifications of dogs. Dogs. Okay? The terms we need to recognize and, what does that say? The terms we need to recognize, organize as follows. Toy poodles, poodles, standard poodles, and Siamese cats, and dogs. Okay? Yes, Sam. Shh. We're not going to edit. Yeah, no, it's the twat. No. Twat? What'd you say? So my grandmother say what? What? She's from Boston. Okay. What would you say? So the thing in the middle is going to be inside all the other circles. It's going to have everything else, all those characteristics with it. So we're looking for the most specific classification. What is the most specific classification of toy poodles, poodles, standard poodles, Siamese cats, and dogs? What's the most specific classification of dogs? Owen.
Classification of like size.
Sure. Does it say anything about size?
No.
Frankie? Is it not? Freddie, sorry. Freddie. Sorry about that. Freddie. How was it disrespecting? I was mistaken. If I would have said, I don't know. Do we need to move on? Somebody else? Did you? Darn it. Okay, what's the most specific? Charlie? Yes, toy poodles. Yeah, where does cat fit in with classification of dogs? Okay, outside. Lainey just said it. She already got it. Siamese cats. It's not even a dog. Quiet, please. Siamese cat is not a classification of dogs, so it goes outside the circle. Now, what's another kind of specific classification of dogs? Sydney? Standard poodle, yep. Standard poodle. Okay? Now, what is one step away from specific standard and toy poodles? Harrison? Poodles. Poodles. Because it's going to be in the outer circle of that. Okay? Put your knees in front, please. It's going to be outside of that because, well, actually, we're going to go to the next step. What's the next step outside of poodles? Yes, Max. Dogs. Now, this is how this works. We have all of these types of things are poodles. Okay, so we have, these are all poodles. All poodles are dogs. Do you agree? Okay, so all standard and toy poodles are poodles. All poodles are dogs.
No, dogs are Siamese cats.
Oh no, these guys are hanging out over here. These cats are just being like stereotypical cats. Okay? But if you go the other direction, not all dogs are poodles, right?
Right.
Okay? And not all poodles are toy poodles because there's also standard poodles. See how when it goes the way down, it's saying, okay, this is this, but it's not necessarily that. For example, you are all my students, but are all students mine? No. Got it? Okay? Now, what does it mean when a group is completely inside another oval? What does it mean when a group is completely inside another oval? What does it mean? Look at the paper, not my face. I know it's a beautiful sight. Not really. Just kidding. I shouldn't say that. Gosh, he is so conceited. Okay, what does it mean? I see you staring at me waiting for somebody else to answer for you. Think. Take an active part in your education. Process. Look at the notes you've had. It actually says it in your notes above it. Jace. A group is completely inside? It's different? So poodles are completely different than a standard poodle?
It's somewhat different.
So somewhat different. Johanna, what do you think?
No, I just wanted to ask you again, like,
Yes, we're good. Thanks. Microphone is on. Dana.
that means it's more detailed.
More detail about it, yes. More detailed classification. I'm going to run on both of what you just said. More detailed classification. More detailed classification. more detailed classification. In this chapter, we are talking about rational numbers. And before we can compare, we must completely understand what each of them is individually. Now, this is the part where I normally had the class take 5 minutes to write down those definitions. Since you guys are being the YouTube capture class, we're not going to take the time to do this, but it is on page, well, you're going to have to complete it. You're still going to be responsible for it. You don't get a free pass. Okay, it's on page 224, but also in your notes, or in your vocab. In your vocab that you had for homework, but make sure that you have it in words, people. Everybody circle what I just did in words, please. 6th period and 5th period did not do very well with that. Okay? So that's that. You guys get responsible for that as soon as I get done with this video. Next part. So I do, for this class, when we're going to use it in the future, in a couple minutes, I do want you to have that vocab of those 3 things available. Now, directions. Label each circle appropriately using terms of whole numbers, integers, and rational numbers. Then use the ignore this one. Number bank below to diagram to place the numbers. Make sure that you're not writing the definition. I see a couple of you doing that. Now's not the time to do it. For each category, give one example of a number that would fall outside of the circles. So, we have our circle here. Let's go 50. There we go. We have our circle here. There are 3 things we have to classify: whole numbers, rational numbers, and integers. By glancing at the definitions that you have from your homework over the weekend, of those 3, which is the most specific classification between rational numbers, whole numbers, and integers? Look in your definitions from your homework. Everybody, right now. Told you to have them out. Okay? Yes. That's, well, you're, okay, well, you need to have it on there. I missed that. I would have marked you off one. But look, integers, whole numbers, rational numbers, right there. Okay, and also, by the way, I don't know if you guys have seen that before, but in your notes, or in your homework, they have an equal sign with a line through it. That means it doesn't equal. Okay? Doesn't equal. Cam, can you help me out? What do you think is the most specific thing? And it's okay, this is mathematics, you're going to make mistakes, so don't worry about it. If you get it wrong, you have a 33% chance of getting it right. Whole numbers, yes, that is the most specific one. Whole numbers. I'm going to do it just like this. Whole numbers. Now, if you can't write this, if you can't write the pound or the number symbol without thinking to yourself whole hashtags, please write the word numbers. Okay? Okay, if you think that is whole hashtags, you are wrong. This is not Twitter. Is that Snapchat thing? It doesn't link though? I don't know. Great. Social media is wonderful. Hooray. Now, next one. What is the second most specific thing? This is something where whole numbers are this, but this is like saying all, no, I'm not going to go there. What's the next one? Yes, Sam. Integers. You are correct, sir. Integers. Because all whole numbers are integers, but not all integers are whole numbers. Did you hear that? Yeah. Good. All whole numbers are integers, but not all integers are whole numbers. And we'll get to that. Now, because we are smart, we can use the process of elimination. What is the third one in there? Rational numbers. You can have it start over here. You can have it start over here. I'm just doing that for demonstrative reasons, so people seeing this can go. You can have your R start down here. R, rational. No hashtags are rational. Okay, kidding. All right, I'm kidding. Okay, now let's look at the word bank below it, and because Lincoln Wildcats are the best, we're going to use Lincoln colors. We already got the orange, now we're doing blue. Whole numbers. Can someone please give me an example of a whole number according to your definitions that you wrote in your notes in the pool at the bottom? Okay, Elena. You can do it. I believe in you. Is that one in there? Yeah. Is it written 11? Yeah. 0.0. Thank you. Okay. What's another one? Yeah. 6. Yes. 6. Dana. 6 over 6. Is that one? No. Is 6 over 6 one? Okay, so you're on it, which is good, but let's try to do it exact from the pool. So you are correct, madam, but it's not one of the choices. Sydney. 9,317. Sam? Lost it? Max. 15 over 3. Snooze, you lose, brother. We got a YouTube video to finish here. Okay, Sam, you got another one? Okay.
2, 1, 2.
Johanna. No, that is not an integer. Jace.
Wait, integers?
Or sorry. That is not a whole number.
17 over 7.
17 over 7. No. Frankie.
17?
Freddie. Freddie. 10, what? 10, 2 over 2. Oh, that is so close to saying how it's supposed to be said, and you did it better than them, and I told myself if they did better than earlier class today, you were going to get a high five. Good. It is not 10, 2 over 2. It is 10 and 2 halves. 10 and 2 halves, which is 11, but that is a whole number. That is a whole number. Okay, is that all of them that we needed?
I just wrote down.
No? All right. 5 of them? Yes, we're good. Now, how about the numbers below it that are not whole numbers, but they are integers and they are rational numbers? We are looking for integers. Lainey. -2, you are correct. Jace? 17 over 7, yes. No.
Erase it, everyone.
I never even wrote that down.
I didn't write it either.
And that's why we don't do notes in pen. Because I'm just going with the flow before I realize what's wrong. Hi. Thank you so much. Dana? Okay. How about another one? We have -2. Come on. Let's get... Yes, answer the question, Corey. Let's get you on this. We are on integers. That's why we have this. Come on, stick with us. Let's go. We got to move along. Cam. -7.0. Yep. Good. Okay, Dominique. -204. There we go. Now we're starting to figure it out. Corey. Come on. There we go. -5 over 5. I think that's what I heard. Right? Yeah. Okay, then there's one more. Abby. -1/4. Good. Negative 1/4. Then we have rational numbers. So those are all the integers. Now, these are things that are not integers, and they're not whole numbers, but they are rational. So, zoom out a bit. These are all rational numbers. Lainey.
The
5.2 repeating, which means that it's 5.2525252525 until the end of time. Okay? Until mathematics no longer exists. Okay? Then we have one more, Owen. Let's give us another one.
0.12345.
Yep. I agree. Okay. Okay. Jake, what do you think? Point 3, you are correct. Point 3. Okay, Dana? 0.88. Jace? Now it's 17 over 7. Okay. Is that all of them?
You should say 6.24.
Abby? 3.5. Now, here I go with explaining how this works. Now, all of these numbers inside that purple highlighter are whole numbers. Okay? Negative 0.7 or negative 7.0 is not a whole number. All these numbers here that are in the yellow highlighter, those are all integers, and some of them are whole numbers. But all the ones that are circled in the green highlighter are all integers. Yep. They are not, wait a second. Yeah, they're all rational numbers, but they're all integers that are not whole numbers. They're all rational numbers, but some of them are all of them are integers. Some of them are whole numbers. Now, actually, you know what? This negative 1/4 needs to be outside of it. Then everything that's blue, these are all rational numbers. Some of them are integers, some of them are whole numbers. Now, can anybody think of a number that cannot be represented in a fraction, as it says for your definition of a rational number? It says all numbers that can be represented as a fraction. What is one that cannot be represented as a fraction? Can you guys think of any numbers? 0 could be 0 over anything. Infinity is a representation of a number, not a number. Yeah. 1.5. New. How about this? Pi. 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 Good. Pi loves you. Write that down outside the circle because it's not a rational number. Be outside the rational number circle.
Can we draw
You draw that symbol, pi.
Mr. Smith?
Yes.
Last year on Friday, March 14th or whatever.
Yes.
So we made pies.
That's cute. Fun stuff. Fun stuff. Okay. Next part. Quiet, please. Next part. Shh. Method, Venn diagram. It is preferred to we write numbers in simplest form. You had this last year as sixth graders. Why keep things complicated when they don't have to be, right? Relationships. Below are some examples, drama, of how we write numbers in simpler forms. For example, 23.40, unless we're talking about money, bling bling, we write it as 23.4. 23.04, the zero serves a purpose, so we cannot simply simplify it any further. Okay? 5.0, the zero doesn't have a function, so we drop it and write it as just 5, unless you talk about a Mustang 5.0. 2/18, we can divide the top and the bottom by 2, so we rewrite it as 1/9. That is equivalent fractions, simplification. You had that last year. We're actually doing that today with my sixth graders. This is an improper fraction, 32/8. So we divide it and write it as a whole number. 32 divided by 8 is 4. And just as a reminder, when you have 32, oh, that's a tiny little pen. Whatever. Okay? It's this, 32 divided by 8, which is 4. 32, 0. Boom. Next we have 25 and 3/13. This is a mixed number, but the fraction is improper. So what we do is we change the improper fraction, mix the number, and then add the number back what you get, which is 23 1/3. Do I need to show you how to do that? I just saw a whole bunch of scowls. Raise your hand if you'd like me to show you how I did it. Okay, good. This is what happens with that improper fraction. Draw. We have 25 and 3/13. Okay? Or sorry, 13/3. Shh. Fellas. Shh. And as I said just over here, what this 13/3 means is 13 divided by 3. This goes in there 4 times. 4 times 3 is 12. Minus 1 means that there's 4 times we go over it, there's a remainder 1. So it becomes plus 4, remainder 1/3. Right? So 25 plus 4 is what? 29 plus 1/3. That was last year's simplifying fractions. Does that make sense then? Okay, because you can't have whatever's left over, that's how many thirds you have left over. Okay? So this remainder is how many thirds you have left over, which comes there, which becomes there. Next one, or the next section, we write a number in simplest form. It is already in simplest form. We write simplified, because this is just like your homework. To identify what sets the number belongs. If it is not a W, I, or R, write none. Use the following symbols. W equals whole number. I equals integer. R equals rational number. What are the possible ways that you could write WIR in a box? I want you to refer to this. Refer to that. So these here, in this box here, what are the possibilities of doing it? What are the possibilities of responses there? It gives you one of them. None. What's another possibility? Okay, a whole number. Now, a whole number. Is a whole number an integer? Yeah, look. Here it is right here. All of that, oh, it's orange also. All of that is inside the integers box. So, if it's a whole number, it's an integer, isn't it? If it's an integer, isn't it something else? a rational number. So you're going to have one option, which is WIR. WIR. What's another option that we could have in there? WIR. If it's not WIR, Harrison? Nope. It will not be W and I, because if it's a whole number, it is an integer. If it's an integer, it's a rational number. Charlie? RIW. That's the same exact thing, just in a different order. Nope, not in this one. Simplified's in the other one. IR. Who said that? Nice. IR. Because you can have an integer without it being a whole number. For example, looking above it, that number, let's see, I don't have it in front of me right now. Look at the number negative 7.0. Isn't that an integer rational number? Isn't this 204? Isn't that a integer rational number?
Let's do circles.
Thank you. Thank you. Thank you. I practice writing circles, you know. I'm kidding. Then what else is there? Yes, Jason. R, just R. So on your homework and the rest of these notes here, those are the four possibilities that you're going to put when it says WIR. Okay, let's do a couple of these examples. No, don't do that. Now, simplest, it says right above it. We're writing what is the simplest form. What is the simplest form? Let's use a different color. Let's use purple. What's the simplest form of 72.0, Sydney? 72, beautiful. And 72, is it rational? Is it an integer? Integer? Yes. Is it a whole number? WIR. We're learning. Yep. Thanks. We're learning. Word up. Okay. See, we're worrying it up. Okay, no. Next one. Number, that sounds too easy. How about number 3? Number 3, is that the simplest form? Yes, it is. So, I'm going to say simplest. No, you can't put no. None? No, you can't put none. That's not an option, that one. Now, is 912 and 7 thousandths, is that a whole number? No. Is it an integer? Can it be represented as a fraction? So we know it's rational. What's the definition of integer again? In your notes?
The whole numbers and their opposites.
The whole numbers and their opposites. Beautiful. So it's not a whole number.
So it's only R.
So it's only R. Beautiful. Just an R. Yes, I did a block letter. Okay. Let's go to number 5. Getting a whole bunch of different kinds. Number 5. You recognize it as pi, so I'm going to simplify it as this. And this is none. Lots of practice as a kid, lots of driving on the highway by myself coming from school to back to my parents' house in Chicago. Yeah.
Have you checked the other classes?
Yeah, here and there. Yeah. Okay, next one. Apparently there's a blue line there. Okay. Number 6. Or actually, let's do one more. Which one do you want to do? Which one do you want to see? Someone tell me. What do you want to see, Corey? What number? Number 7. Okay, so we have shh. What is the simplest form of negative 9/90ths? So not negative 9/90ths. Okay, what's the simplest form there? Let's see. Who hasn't? Mulva Hill, why don't you help me out here? I haven't heard your voice all day. Negative 9/90ths, that's the simplest form?
Yes.
Okay, what if I divided the numerator by something and the denominator by the same thing and got a different fraction? What would that be? Is there any number? Do they have any common factors? 3? Okay, so let's try 3 and see where we go from there. Don't write this. So then we have 3/30ths. Right? So we can go further than that, can't we? What does 3/30ths simplify to? 1/3? 3? 1/10. So let's just divide this by 9 and that by 9, and we get 1/10. Because that's how you do some. Oh yes, thank you. Good catch. Yes. Okay. Negative 1/10. And what is that? Is it a whole number? No. Is it a whole number or its opposite? No, so it's not an integer. What is it? Rational. Are there any questions about how to do, which is exactly like this, which is the homework? Are there any questions about this? Okay, so that's all she wrote. Take care. That takes care of first day of chapter 5.1.